Consider an experiment we have designed to test a physical model, but where we cannot directly measure one of the model parameters. For example, we designed an experiment that looks at Newton's second. Acceleration is force divided by mass. We want to apply the same constant force from a fan on different mass carts and test if the acceleration of the carts is proportional to the inverse of the mass. Our independent variable is the mass, and our dependent variable is the acceleration. We can measure the mass of the carts directly using a scale. However, we do not have the tools to measure the acceleration. We can find the acceleration in an indirect way, however, using a motion detector to measure the position of the cart as a function of time. We then get the acceleration of the cart from a quadratic fit of this data. We repeat this process for different masses, recording the acceleration fit parameters from each experiment. Finally, we plot what we measured for the acceleration of the carts for each of the different masses, which is what we wanted to test. Multiple stage data analysis means that our measurements are made using several models and intermediate steps. When designing an experiment that uses multiple stage data analysis, identify the model you are testing with its independent and dependent variables. Determine what measurements will be made indirectly using other models. Then repeat this process for each data analysis stage. Although it is typically better to use as few stages as possible, there are experiments where the measurements can only be made indirectly, requiring this type of multiple stage data analysis.